This presentation focuses on effective error handling techniques, particularly the use of result object to manage expected failures. We will cover the importance of robust error handling strategies and the advantages of using result over traditional methods. In this presentation, we will first discuss the importance of robust error handling and common strategies along with their drawbacks. Next, we'll dive into result object, exploring its purpose and structure and how it compares to traditional error handling. We'll also examine its application, user input validation, file existence checks, and conclude with best practices and future trends. Error handling is a critical aspect of software development as it helps maintain the stability and reliability of applications. Understanding various error handling strategies and their limitations can enhance the quality of your code. Robust error handling ensures the application can gracefully recover from unexpected situations and provide user with helpful feedback. It also helps developers track and fix issues more effectively, leading to improved software quality. Common error handling strategies include exceptions, error codes, and conditional checks. However, these methods can lead to complex and hard to maintain code, making it challenging to manage errors effectively. Result object is a modern approach to error handling that encapsulates success and failure states. It allows developers to express outcome more clearly, improving code reliability and maintainability. Next, we'll explore the structure and purpose of the result object, comparing it with traditional error handling methods to understand its advantages. The result object is designed to represent the outcome of an operation. It typically contains two components, a success value and an error value, allowing developers to handle operations without throwing exceptions. A typical result object includes a Boolean indicating success or failure, a value representing the successful result, and an error message or code. This structure facilitates clear and concise error handling. Unlike traditional error handling methods that often rely on exceptions, the result object provides a more explicit way to handle errors. This leads to cleaner code. The result object can be effectively used for validating user input, providing clear feedback on validation success and failures in a structured manner. Common scenarios include form validations, data type checking, and input length restrictions. The result object can help manage these validations by capturing success and error states. Implementing the result object in input validations involve defining validation rules and returning a result instance that indicates whether the validation was success or failed, along with any relevant error messages. So let's look at a simple validation of user input. In this console application, we ask the user to enter a name. And then if the name is just empty or white space, we will return an error. Otherwise, we'll just say hello. So here when we run it, if I didn't pass anything, it'll ask for a name. If I just typed in a few spaces, it'll still give an error. And if you give it some name, it'll just say hello. Now, we're going to add one more parameter. Let's go with age. And this is also straightforward from top to down. We ask for the name. We do the same validation as before, and then we ask for age. Age, first we check if that string is not empty. Once it's empty, we try to convert it to an int. And once it's an int, if it's less than 0, if it's a negative age, then we give an error. Otherwise, we just display hello, the person name, and age. Now, I'm going to go into a third scenario where the input is coming from the command line. So here, the name and age is coming from the command line. And the code is pretty similar to what we had before. The only disadvantage of now this style is the moment a single check fails, we exit the program. So maybe the user gave invalid name as well as invalid age. So it would be nice for the error to give that information. In this case, it won't do that. It will just tell you one at a time. And this is common in quite a few scenarios. And next, we'll also look at how we can improve on that. Okay, so we run this, and we need to pass name and age. So I'm going to pass. So here's empty name, which is invalid, and I'm passing string for age. Both are invalid. But when you run, I don't get two error messages, right? I just get one. It's just that you didn't enter the name, and we exit the program. So let's look at, we can improve that. And this sample shows that example, where we could have a collection of errors, and you will see both the errors coming together. So basically, all we have is an empty collection here. And when the name check fails, we add it to the error collection. And if the age check fails, we add that to the error collection. If there are any errors, just print out the error messages. Otherwise, give the hello message. So this is the So same test as before, but now see how we are able to show both name and age group. So far, everything that we have seen in the sample is just traditional programming. Next, we're going to look at the same example, but using a result object. So what's happening here? We run our check, and the check failed. Then we create a validation error and store it in the result. Otherwise, we will say it's a success, and we store the name. So now the result object, once the statement executes, either has the success value or the failed validation error message. Similarly, age is doing the same thing. We run through all the age check. If the validation failed, we return a validation failure, and we end up with two results objects. So here we have the name result object and the age result object. If both of them are success, that's what the result object gives you. It has a Boolean where you can ask it if it is a success or a failure. And if both the scenarios are, both the values are in a success state, we can say hello world. Otherwise, you can get the error information from the error object on the result object and display that out to the screen. Let's show the example of that. So same as before, we're getting both the errors. If the behavior is still the same. We give it it all works fine. So now I've introduced the concept of result object. Now the advantage result object gives us, we can write monads that expect these results objects and allow us to chain functionalities. And that's what we're going to take a look at here. So here we have this method called validate name, which is same check as before. We're checking if in case of failure, we return a validation failure. And similarly, we have the age check. So that has not changed. What is interesting now is that when this code runs, it returns a result object. And this code also returns a different result object, as we saw in the previous sample, and combines these two into a single result. And if the combined result is in a success state, then it will enter this method called tap, and it will print hello to the user. In case of error, it'll go into the tap error method, and you get the error messages. So this will still behave as before, but you're kind of getting this Fluent API style. because of the fact that every function is returning a result, all these monads can be used to chain and follow the different tracks. So tap gets called on a success track, and tap error gets called on the failure track. And there are other methods, like bind is one of the most commonly used for following a success track. But anyway, let's take a quick look at this example here. So good value works same as before. And then if I here where both the values are invalid, it tells you that the field name you did not enter it. Similarly, age is not correct. So this covers a console application. I wanted to keep it console application, although most of my stuff is in web, which is the next example we'll go into. So we can see some more functionality. But here I just wanted to start with just normal plain C code with a simple validation and then expand onto it, right? So the first example we had here, we just had name and its validation. In the second example, we added name and age. And we can see the code is kind of getting longer. Of course, we could refactor this and clean it out, but I just wanted to keep this top-down approach so it's easier to read. And then we went into a scenario where we're taking this from command line. And when we get multiple inputs, we want to also show in all the inputs that have failed. But in this example, it doesn't do that. It just, the first failure, it sees, it returns to the user. So now the user will correct that mistake, rerun the sample, only to figure out something else is wrong. So that's why we have the fourth example where we collect all the errors into a collection, and then the user knows all the things that's wrong about their input. And then we go into the code where we start using the result object, where at this point we can't see too much of an advantage. It just gives you that this is how it's done, where we stash the result object and the age object, and we can check. Then the benefit starts coming in when we come into the last example, where having that standard result object, we are able to start having methods that can take the right track, follow the failure track or the success track. And this is where that concept of railway-oriented programming comes from, and start chaining these things. And this makes it convenient for the developer that they don't have to write code to check if the result is in a success or fail state. These monads will take care of it. So now let's look at a web example. So here we have same code that we had from the console application. There's a validate name and validate age, which returns a result object in case of success or failure. Now, this is the get part. So here we have a method, and we see similar code where we validate the name, validate the age, and combine the result. If the combined result is successful, then it goes into this bind where we return the success string saying hello with that person's name and age. And that string is then passed on to this helper function, which comes from my library that converts it into HTTP. So if the result is in success state, it will return HTTP OK. Or if it's in a fail state, then it would return the validation failures. So for these functionalities, they come from the two library functions that I've written. So the monad that allows for chaining comes from the functional DDD railway-oriented programming library. And to convert the result object to HTTP error comes from the ASP NuGet package. So let's see this in action. So in the first scenario where we have a proper name and age, this should return a success. So let's call it. And we have that hello name and age coming back. In the second scenario, age is not an integer, and so that should fail. We expect a bad request. And we do see bad request. The library understands the result object and it's able to convert the validation error to the proper RFC 9110 format. So you get the problem details information that is useful to the end user. Like here we have that it's age and age is invalid. And here's an example where we are passing a space for name and this is still not an integer. So that should fail with multiple errors and we get both the errors in one go. And so this is kind of the advantages of using the result object in combination with the library that I've written. Allows you to write this succinct code without and let the monad take care of taking the error path or the success path and then converting it to the required HTTP result. Using the result object for input validation promotes better control flow, reduces exception-related overhead, and enhance code readability, making it easier for developers to trace issues. Using result object for checking file existence simplifies error management and file operations, allowing developers to handle scenarios where a file is not found without throwing exceptions. File existence check can often lead to errors, especially in asynchronous operations. Managing these errors gracefully is essential for stability and user experiences. As an example, maybe a business requirement is to check if a file exists. If it exists, it's not an error. Or it could be the reverse, where the user trying to open a file, but that file does not exist. These are expected failures. And for these, we would use a result object. On the other hand, if the file is corrupted or when you're calling out into a network, the network disconnects, those are exceptions. So in those scenarios, throw an exception because those are exceptional cases. So this is how you have to also differentiate when to use result versus throwing exceptions. So when implementing file checks with result objects, you can return a result indicating success if the file exists or an error if it does not, along with helpful information. In this section, we'll discuss best practices for using result object as well as performance consideration to keep in mind to maintain efficient and clean code. It is essential to understand that when to use the result object versus exceptions. While result is great for expected failures, exceptions should be reserved for unexpected errors. This ensures a cleaner error handling strategy. Using the result object can improve performance by reducing the overhead associated with throwing and catching exceptions, particularly in scenarios with frequent error handling. Adopting the result object promotes clean and readable code structure, making it easier for developers to understand and maintain code bases without convoluted error handling logic. In conclusion, the result object provides a robust framework for managing expected failures. As software developers continue to evolve, embracing this approach can enhance code quality and developer productivity. We covered the importance of error handling, the structure of result object, its application in user input validation and file checks, and best practices for implementation. These points emphasize the value of adopting the result object. As a software architecture evolves, we can expect to see a greater emphasis on structured error handling technique like the result object, leading to cleaner and more maintainable code. To improve error handling practices across the industry, we should encourage the adoption of result object by sharing its advantages and successful case studies we can help developers embrace this approach.